Okay? And how did it happen? Because we added what? CV. So if you come across the term swamp amplifier circuit, it simply means that the amplification got big because of adding a capacitor in the circuit. And what does the capacitor do? It bypasses the resistor, and so if I take a component out of the denominator, my answer becomes big, right? And in this case, it is 79 times big. So now let's turn the page, page 11. Two graphs. The first graph is V out before C3. Which one is C3? C out. So we'll call C3 C out. This is C3. Okay, we can call it C3 or we can call it C out. So does that mean that I'm trying to measure V out? What is the point before C out? Is it this point here? So at this point, my output signal, which is here, is going to be riding on top of VC. So that means a signal, and it says right there, superimposed on VC. So what I do is I indicate the VC value here, which is a DC value. VC is a DC value here. So I'm going to show it right here with the dotted lines. And I'm going to put a VC there. And VC is a value I calculated for my DC analysis, and it's on page 8. How much was VC? Fourth calculation down. 9.2 volts. So if I was to measure a DC value here, it's 9.2 volts. So now what happens is my signal, which is 79 times bigger, is going to be riding on top of that. Did I forget to do a calculation at the bottom of page 10? V out. AV times V in. So that's 79 times 50 millivolts. How much? 3.95? 3.95. Okay, so that's my V out. It is 4 volts up, 4 volts down. Okay, so that's what I'm going to show. It's inverted. Okay, the signal in a common emitter is inverted. So this is what's going to happen. So I'm going to be at 9.2. This point is 9.2 plus 3.95. And this point is 9.2 minus 3.95. So 13 volts and 9 minus 4 is 5 volts. So on a scope, this is my scope. Okay, if I set my ground line here at the middle and I set the scope to DC, you know how we have that DC AC switch on the scope? If I set it on DC, what I will see is that picture here. Do you see that? And this is how much? 9.2. So that is before C3. What is V out after C3? So my second graph is here. V out after C out. Where is after C out? This is before. This is after. is after the signal, after the capacitor. So the capacitor, what it does for a DC signal is that it blocks the DC signal, okay? But it lets the AC signal through and blocks the DC signal. That's what a capacitor does. So what happens here? 0, no more on that 9.2 volt offset. Instead, this is what I will see at VL, after CL. Okay? 0, 9.2 volts here, no, 3.95, and minus 3.95. Okay? And on a scope, what would I see it after C out? I would see that graph here, not shifted up. That's what that means. The whole point of doing this is to tell you that in an amplifier circuit, we've got DC voltages and we've got an AC voltage coming in. And so there are two kinds of voltages at work here. There's DC plus AC, and basically this AC signal is shifting with the DC signal. At this point, it's going to be shifted by VB. At this point, it's going to be shifted by DC. Do you see that? Okay. So that's our notes for example 2. Let's go to example 3 now. What's different about example 3? We have an RL. So now we have CB and we have RL. Okay? So can you write a note at the top of the page, page 12, example 3, indicate with RL with CB. Okay? And RL is 10K. Okay, so DC analysis. With any amplifier circuit, we have to do DC analysis and AC analysis. What is DC analysis? It is this part of the circuit where, for a DC signal, a capacitor is open. Okay? This is open, this is open, this is open. So, for any case, the circuit is standard, which is my voltage divider. It's only with AC that I have the capacitor closed. So, let's do the calculations.